Hi, I'm Sean Wassman, and this is Michael Kim from StrongArm, a SolidWorks user.
StrongArm Technologies enables active workers, who we call the industrial athletes, to do their jobs safer with greater performance and safety.
So this was all designed within SolidWorks itself, correct?
Yeah, from day one till even now and going forward, we've been designing everything from the 18 different injection molded plastic parts to the soft goods themselves, as well as the aluminum clutch housing here.
What are some common mistakes when it comes to simulation?
I think some of the common mistakes are definitely assuming the wrong conditions to the part and not fully understanding how it behaves, and also in terms of the software limitations, not knowing how certain things come out when you apply different conditions. And I think also some people have this notion of trying to find something that they originally had some sort of idea for, and not really understanding the data, or what they put in or what they get out, and trusting that and not being able to do that with clear accuracy. And I think that's probably one of the worst things that we can do as engineers, is when we're fixated on a certain idea or value and we just work to try and get that when our data tells us otherwise. And we've seen people do misleading things based on their findings, or can even have small decimal errors where they put something, a zero, an extra zero somewhere, or they're using a different material that has different properties and they didn't double check. And those are the really silly small mistakes that can really throw off your calculations.
What about boundary conditions?
Yeah, boundary conditions, again, it's super huge because it affects the data that comes out and how the part behaves in the simulation. And that really ties back into really understanding each part, its specifications, what its actual use case is going to be. And that's the only way to really understand boundary conditions.
So you've done your simulation, you've done the testing, and they don't match. How do you go back and error check to find where that problem was in your simulation?
Whenever it doesn't match, and that that happens frequently, but you really have to embrace it and understand that you just have to double check and just make sure that everything that you did from the beginning was correct. And one way to do that is to have an idea, a set of assumptions and test parameters, and know exactly what you're testing for, so that when something goes wrong, you're able to try and track down your process, what you put in, what you got out, what you were looking for, why you did certain things. And then from that, you can start changing certain parameters to see how it affects your values. And then once you test it with the real life thing, you can basically backtrack and say, oh, it failed here, or this doesn't look right. Let me go and check and see if we put everything in correctly.
So kind of an incremental error check.
Definitely.
This has been Sean Wassman and Michael Kim from StrongArm, and he's a SolidWorks user.